All right, welcome. These are the notes for Boolean values and logical operators. I've got my starter code all loaded up here and ready to go, including the import random module right at the top. So we'll use that later on in these set of notes. And also in these notes, I'll just note we're going to use the shell a little bit. You can see in the first couple examples, we're going to look at the shell. Just a reminder, the shell, right, in Replit is going to be this, in my case, the bottom screen here, where we're used to seeing the output. And remember what the shell can do is it allows us to test code out. So if we type something, we can press enter and get immediate feedback. Of course, this gibberish it doesn't recognize. It says the name A is not defined. It doesn't know what this is. That's a name error, right? It's trying to read it like a variable that doesn't exist. Clear my screen. Now we've already looked at Boolean values a little bit in class, and we recognize them as being true and false. And these must be capitalized in Python. And if they're not capitalized, it won't work. And so we're going to see that in the shell here when we test it out. So go ahead and jump down to the shell. Go ahead and type in, first of all, a capital true. What the shell is going to tell you when you press enter is that it recognizes this capital true as the Boolean value true. And go ahead and save everything we do in the shell here. We're going to put it back in our notes by copying and pasting it in a second. But then go ahead and also try false, just to recognize that both true and false, if you type them in, Python recognizes those as true and false. The Boolean value is true and false. And if you do a lowercase true, for example, it's not going to recognize it. It doesn't recognize it as the Boolean value. It's trying to read it again as a variable. It says name error. The name true is not defined. So it doesn't know what it is. Now we can tell that these two values are Boolean values if we use the function type, right, the built-in type function in Python, to check to see what the type of the capital true is. It tells us that it comes from the class bool for Boolean. Right? And it's the class bool, therefore it's the type bool. So the type of value is a Boolean, same for false, Boolean. It's important to note here that the capital true and false are not recognized within strings. So if you do like type false as a string, for example, that's a string. Even though you capitalize it in there, it's string is still a string. So those are Boolean values in Python. So we're going to go and copy this code. The keyboard shortcuts do not work in Replit, so you need to right-click on your highlighted section of code, go up and select Copy, go up to wherever you want to paste, and Control-V to paste it in. And it gives you some funky output here. Didn't used to do this, but I'm just going to go ahead and change these boxes just because for me, recognize this better. These are the greater than symbols. I'm just going to make these all these boxes. I'm just going to go ahead and change. It just looks a little bit better. All right. So we're going to go ahead. I'm going to go ahead and clear my screen. We're going to do the same thing for expressions, because in Python programming languages, everything needs to be evaluated down to a true/false to these Boolean values. So we can prove that different things do evaluate that by testing it out in the shell. So we'll do this again down here. All right, so one thing we could test, for example, we could test is 5 equal to 5. True. We can look at different comparison operators, so not equal to 5. That's false. 5 less than 10. That's true. 5 greater than equal to 10. That's false. So we can use this little scratchpad shell down here to test these things out. If you ever need to test if something evaluates to a Boolean value, which Boolean value it evaluates to, we can test it down here. Yeah, so keyboard shortcut doesn't work. It gives you this keyboard interrupt. So instead, we need to right click and copy this, paste it up above. And again, I'm just going to go ahead and change all currents to this little caret. All right. Now, because things need to evaluate to Booleans, sometimes we have compound conditions, things that we have to check multiple things of. And an easy operator we can add to our code are these things called logical operators. My screen comes back here. Sometimes your applet will do that. If you just go ahead and refresh your window, more often than not, it'll get you back where you want to be. Okay, logical operators, the three we need to recognize are and, or, and not. And they have an order of precedence, and that is that not is going to be evaluated before and, which will be evaluated before or. You can see this entire order of precedence on the online textbook. Got it pulled up in a separate tab here. The precedence of operations. So you can see that the highest precedence is going to be an exponent, and the lowest is going to be the or operator. Right, so here you can see the full scope of that. All right, so knowing that now, we're going to jump straight to a challenge. And I want you to try this, right, and maybe struggle with it a little bit and try multiple ways to see if you can get it to work. But the challenge is to generate a random number between 1 and 13, and then print out that your number is lucky if the number is 7, 11, or 13. All right, and use the logical operators to try and accomplish this. So go ahead and pause the video and try that out. All right, so another random number scenario. So in this case, we're going to generate a random number that will be our lucky number. And we'll use the random function in this case to do that. We'll print it out so we know what it is. And then here's where we're going to use our logical operators. So here's where we can check if this lucky number is 7. Logical operator here is or, because I said it could be any of those numbers and it's lucky. So if it's 7, or if it's lucky num 11, or lucky number 13. Any of those, you can say your number is lucky. Now, important to note, some of you may have tried before arriving at this conclusion, you may have tried it this way. You may have tried to check if the lucky number is 7. And I say you may have tried this because this is a common mistake. And then used your OR operator, but then checked immediately for 11, 13. You could have done this too, right? So we'll print the number and we'll check both these out. Oh, up above, where we did our shell testing, we need to make sure this doesn't run as code. So I'll use a triple quote. that out. Do the same for the second set here. Nope, spelling error. All right, another syntax error here, name error, wasn't recognizing what I was typing. Okay, so it says 2, your number is lucky. So here's you can see this logic error, right? The code works fine, but there's something's logically inconsistent with what we wanted. And that's because this is the true statement right now. Because 11 all by itself or 13 all by itself are evaluated to true. Right, so this statement here is always going to be true because 11 and 13 are always evaluated to true. So we need to be careful about this. So we'll just say these are always true. So we need to be careful about that. So we don't want this to run because this is not going to work. Instead, run this a few times to test out. So 4, 7, lucky number. So now it appears to be working correctly. Okay, so the OR operator here in this case is the only one we actually used. You can use the same type of logic for an and then similar for not as well. So we'll look at those in a different example. Okay, so moving on. I want to point out in a little more detail that non-zero numbers and non-empty strings are evaluated as true. To show you this in a bit more detail. And we can see this if we just write a series of if statements to check it out. So we could say like if 1, for example, evaluate to true, high, a float value, all those happen to be true, then all evaluated to true. Okay. So basically, if this prints out, right, we'll know that they all evaluated to true. Also say actually, let's start out by just running this. So in the output here, we see all evaluated to true, right? These are all true. All right, so we can check the opposite of that. Things that evaluate to false are things like 0, 0, 0, and empty strings. With the OR operator here now, we can check if any of these things evaluate to true, this whole thing should evaluate to true. It should print that at least one evaluated to true. But if not, you can just print out that all evaluated to false. Here we see in the output that, in fact, they all evaluate to false, right? So these are 3 examples of things that evaluate to false always, and then any of these would evaluate to true. Okay, so then on to this exclusive network challenge. So in class, we'll do this with a partner. If you're on your own watching this, just go ahead and try this on your own. You're going to write a Python program that's going to grant a user access to an exclusive computer network. So another password program. You're going to get a username and password from the user, and then you're going to check and see if the username password match any of the exclusive members of your network. So you can decide what those username password combos are. ahead of time, and then you can write your program such that you only grant access to these users to your network. Now, another scenario I want you to do is if the person puts in guest for the username or the password, I want you to go ahead and grant them access. And then if they're granted access, you should print a message saying that they got access. And if they didn't get in, if they're denied, then print a message saying that their login credentials are incorrect. And if you want, here's some extension challenges here as well. All right, so go ahead and try that. All right, welcome back. So solution to that problem, I'm just going to go ahead and copy and paste the solution in, and then we'll just go through it. So in this case, I asked you to get a username and password. So I just went ahead and did that with 2 inputs. And then I'm going to check the combinations. And if the username and password match, right, so we're using the AND logic here, then we're going to grant them access. In this case, I grant access by keeping track of a variable I call security. So if security is 1, then they get access. All right, so there's a bunch of combinations, a bunch of users that get into my network. There's 4 users here that could get access, or they could get access through guest access. So if they put guest for the username or password using the OR operator, they also get in. The scenario, if none of the above are true, the else is that they failed to get in. And then if they do get in, here's my welcome message, welcome to the exclusive network, whatever the person's username was, or if they're the guest.